The observable diameter of the universe is approximately 46 billion light-years. Pay attention. I say observable. We will also talk about what lies beyond. To understand this, let's begin with what a light-year is. The speed of light refers to the distance light travels in 1 second. Light is massless, and it means 300,000 kilometers per second. At this speed, light can travel around the Earth, whose circumference is approximately 40,075 kilometers, in about 0.13 seconds. In other words, it can circle our planet in much less than a second. So we are talking about a speed that can go around the Earth in a fraction of a second. And if we were able to move at 300,000 kilometers per second, reaching, or even approaching, the boundaries of the observable universe would take a full 46 billion years. Think about that. That is the amount of time it would take, even at the speed of light. In other words, even if we were traveling thousands of times faster than today's technology allows, even if we moved at the speed of light without ever stopping, it would still take 46 billion years. It is difficult to comprehend. And beyond that, there is more. There may even be other universes, as suggested by the theory of the multiverse. We will come to that as well. But what lies beyond that? And beyond that? And beyond concepts like infinity? Things we cannot truly comprehend also begin to come into play. So let us begin with the observable universe we are in right now. Let's give an example. The universe was formed approximately 13.8 billion years ago, and the universe is expanding in all directions at an accelerating rate. If the Earth's circumference were traveled continuously at 100 kilometers per hour, it would take more than 17 days. With a passenger airplane, traveling around the Earth would take more than 2 days. The distance between the Earth and the Moon is approximately 384,400 kilometers. If we think of Earth's diameter as a unit of measurement, we would need to place about 30 Earths side by side in order to reach the Moon. If one were to go to the Moon by car at 100 kilometers per hour, it would take more than 6 months. At the speed of light, the Moon can be reached in 1.3 seconds. To this day, 12 humans have walked on the Moon. Let us give another nearby example. If one were to travel from the Earth to the Sun at 100 kilometers per hour, it would take approximately 177 years. With a passenger airplane, going to the Sun would take about 19 years. At the speed of light, the Sun can be reached in 8 minutes. If we measure the distance between the Sun and the Earth using Earth's diameter, we would need to place about 11,700 Earths side by side. The Milky Way galaxy is approximately 120,000 light-years in diameter, and it contains approximately 100 billion to 400 billion stars. Current observations show that the great majority of stars have planetary systems. For this reason, it is thought that there may also be approximately 100 billion to 400 billion planets in the Milky Way alone. In other words, when the total number of stars and planets in our galaxy is considered together, that number may reach between 200 billion and 800 billion. It is estimated that there are approximately 2 trillion galaxies in the observable universe. If we assume that an average galaxy contains 100 billion stars, then the total number of stars in the universe is approximately 200 quintillion, that is, around 200 sextillion. If we assume that the number of planets is at least this many as well, then the total number of stars and planets together in the universe is approximately 400 quintillion. That is, it reaches the scale of around 400 sextillion. For comparison, the number of grains of sand on Earth is approximately 10 quintillion. In that case, the total number of stars and planets in the universe is about 40,000 times greater than the number of grains of sand on Earth. Even if you gathered all the sand from all the beaches on Earth and then added that same amount of sand tens of thousands of times more, only then could you begin to approach the number of stars and planets in the universe. I hope we are beginning to understand the size of the universe and its relativity. As for Neptune, if one were to travel there at 100 kilometers per hour, it would take more than 5,000 years. Traveling to Neptune by passenger airplane would take about 600 years. The average distance between the Sun and Neptune is approximately 4,503,000,000 kilometers, and this distance corresponds to about 353,000 Earth diameters. In other words, about 353,000 Earths lined up side by side. There is no exact consensus regarding the boundary of the solar system. According to some definitions, the boundary is the orbit of Neptune. According to others, the boundary is the Oort cloud. Reaching the Oort cloud at the speed of light takes about 1.5 years. The Voyager 1 spacecraft was launched in 1977. Voyager 1 left the solar system in August 2012. Voyager 1's distance from the Earth is approximately 22 billion kilometers. If one were to travel at the speed of light, reaching Voyager 1 would take about 21 hours. Proxima Centauri is approximately 4.2 light-years away from the Earth. If one were to go to Proxima Centauri at 100 kilometers per hour, it would take about 47 million years. So think of it this way. If we traveled continuously at the speed of light, that is 300,000 kilometers per second, it would take 4.2 years. But at 100 kilometers per hour, it would take about 47 million years. And when we consider that there are planets and regions of the universe billions, even hundreds of billions of light years away, we could actually say that this is relatively close to Earth. Sirius is approximately 8 light years away from the Earth. Betelgeuse is approximately 645 light years away from the Earth. Betelgeuse is about 1,000 times larger than the Sun. The diameter of the local stellar neighborhood is approximately 50 light years. At Voyager's speed, this distance would be covered in about 1 million years. Humanity's radio signals have reached an area about 160 light years in diameter. Within this region, there are approximately 3,000 to 5,000 stars. The Milky Way galaxy is approximately 120,000 light years in diameter. The thickness of the Milky Way is approximately 1,000 light years. There are approximately 100 to 400 billion stars in the Milky Way. Counting to 1 million takes about 12 days. Counting to 1 billion takes about 32 years. The Andromeda galaxy is approximately 2.5 million light years away from the Earth. The Virgo supercluster is approximately 110 million light years in diameter. The Virgo supercluster contains thousands of galaxies. It is estimated that there are approximately 2 trillion galaxies in the observable universe. The cosmic microwave background radiation is accepted as the radiation left over from the Big Bang. This radiation represents the boundary of the observable universe. And now, let us stop for a moment and think. We live on a planet. That planet orbits a star. That star exists within a galaxy that is only one among hundreds of billions of stars. And that galaxy, in turn, is only a small part of a universe made up of trillions of galaxies. But the story does not end here. Because most of the atoms in our bodies were formed inside stars, that exploded billions of years ago. So in fact, we are living beings, formed from the ashes of stars. When we look at the sky, we have a far deeper connection to those distant points of light than we may think. At first glance, the vastness of the universe may make a person feel small and insignificant, but at the same time, it reveals another truth. The universe has produced a consciousness capable of becoming aware of its own existence. And right now, that consciousness is trying to understand the universe itself. Perhaps that is why, when we look at the universe, we do not see only the stars. At the same time, we also see ourselves. Because in the end, we are not outside the universe, we are inside it. In fact, perhaps a more accurate way to put it is this: the universe may be using our eyes to look at itself. The diameter of the observable universe in kilometers is approximately 435 quintillion 160 quadrillion kilometers. If we wanted to fill this distance by placing Earths side by side, we would need approximately 34 quintillion Earths. And what about multiverses? What if space consists of billions and perhaps trillions of universes? Just as our own universe contains trillions of stars and planets, what if universes are like grains of sand within a much larger system? And what if that system itself corresponds to a grain of sand inside another system, and perhaps an infinite relativity in this way? And what if the microsystems within our own bodies are structures within themselves as well? Quite thought-provoking, isn't it? So where are we, really? And how can reality, perception, and existence truly be comprehended at the boundaries of understanding? And what is truth? And how did everything begin?